All right, section 6, we are going to talk about factoring and patterns in factoring that are a little bit more complicated or involved than what we've been doing. So let's go ahead and get started here. We're going to first talk about a pattern that is review. It's difference of squares. It's a pattern that showed up when we first learned about quadratics in chapter 3. And this is the form that it takes. If you have a squared minus b squared, so something squared minus something else squared, then you can break it into a minus b and a plus b. Okay, so for instance, x squared minus 64, if we were to factor this, we might notice, or should notice, that this is x squared minus 8 squared. So that could be broken into x minus 8 and x plus 8, following the pattern there. Okay, so that's the difference of squares. Now, how is this, how can we build on this? Well, one thing you should always do first is try to factor out a monomial. And now, in this one, there was no monomial to factor out. But in this one, there is. So I look at the greatest common factor of 4 and 36. Turns out that's 4. And then the greatest common factor of x cubed and x to the 1 is x. So I'm going to take out a 4x. On the inside, I will be left with x squared minus, excuse me, 36 divided by 4, which is 9, so x squared minus 9. And so then we factor the monomial out, and we see that x squared minus 9 is a difference of squares itself, so 3 squared is 9. So we can break this into 4x, and then x minus 3, and x plus 3. Okay, so that's the factored form of that. Now, this format can work for problems where it may not be obvious that it will work. It works in any situation where you have something squared. So maybe you have like triangle squared minus square squared. Okay, then that would break into triangle minus square times triangle plus square. Okay, I ran out of space. I apologize. But the idea here is that anything that takes this format, you can apply the rule. So m to the fourth minus n to the fourth, it may not be obvious that this takes that format, but I can rewrite this in this way. So I can rewrite this as m squared squared minus n squared squared. So taking the place of a is m squared. Taking the place of b is n squared. And so I can break this into, well, so it would be a minus b, so a is m squared in this case, minus n squared, and then m squared plus n squared. Okay, again, just following the format, a minus b times a plus b. Then I can split this up because I can factor this because it's also a difference of squares. So you can break this into m minus n times m plus n. This is the sum of squares. There's no rule or property for that. That just has to stay as it is. All right, let's talk about quadratic form. So this is a new one here, I believe, okay? So quadratic form, actually, it's similar to this. What we did here is we turned this into a, so that it was formatted as a quadratic, right? So this was a thing squared minus another thing squared, which fit a quadratic pattern. For quadratic form, it's the same kind of idea. If we can make a trinomial that we're given look like a quadratic, then we can use the rules for factoring quadratics to break it up. So if I have this, x squared squared plus 3x squared to the 1 plus 2, that's in quadratic form. And actually, if you look at the back of your, let's see if I have, I guess I don't have a good general example there, but it's basically anything that, so anything that you can do in quadratic form, maybe take triangle squared plus or minus, doesn't matter, triangle to the 1 power plus some constant c, some number out there. Anything in that format you can use to break it into two parts as you would a quadratic. Let me show you what I mean. So we have x squared squared plus 3x squared to the 1 plus 2. So I look at the 3 and the 2. So if I'm going to break this up, I need numbers that multiply to give me 2 and combine to give me 1. Well, the only factors of 2 are 2 and 1. And so it's got to be 2 and 1. But instead of having x here and x here, we're going to have x squared here and x squared here. All right. And this will be plus 1 and plus 2, or plus 2 and plus 1. Okay, so there, that factors, because we notice that it looks like a quadratic, we can put it into the form of a quadratic and then factor it into its parts. The only thing that changes is instead of having x's here, we have x squareds. Do the same thing with number 5 here. This we can write in quadratic form. You don't have to do this every time, but I do think it's really helpful. So if we take x squared like that, that's x to the 4th, minus 29 x squared to the 1, taking the place of that 1 power term, plus 100. You think of this as like a would be 1, b would be negative 29, c would be 100, like if it was standard form of a quadratic. Okay, so then we're looking for numbers that multiply to give us 100, but combine to give us 29. Okay, so you can play around with what numbers that will be, but you'll find that it's 25 and 4. Okay, so break it up like this. So we'll have x squared, and then we'll have minus 25 and minus 4. Okay, and then might notice that x squared minus 25 is a difference of squares. X squared minus 4 is a difference of squares. So you can actually break it up even further. You can go x minus 5, x plus 5, and then x minus 4, x plus 4. Okay, so there it's completely factored. We started off in quadratic form. All right, we're going to skip this one. I don't think we have to do anything like that on the quiz or in the assignment. Now we're going to talk about sum and difference of cubes. And let's see how we're doing on time here. Okay, we're doing all right. So sum and difference of cubes. Again, we always start off checking to see if we can factor out a monomial. I know sometimes I forget that, but it looks like there's no monomial that we can factor out of this one. So we have 2 rules. One for if I'm adding 2 cubes, 2 numbers or terms that are cubed. Another one if we're subtracting them, so a cubed minus b cubed. And the way that we approach these is we figure out what a is, we figure out what b is, and we just put them into the formula. Okay, so if a is 7, everywhere you see an a, you're going to put a 7. If b is 2x, everywhere you see a b, you're going to put a 2x. Okay, very important to identify a and b first. So let's try that on this problem. So I can see that this is x cubed minus 27y cubed. It's not quite in proper form because we need to know what number cubed gives us 27. So x cubed is fine, minus, and it is 3 cubed that gives us 27. So our a in the formula here is x, and our b is 3y. Okay, so this is sort of like when we did expanding binomials, where we had to identify the a and the b. But anyway, so let's follow the format then. It says if we're doing difference of cubes, we're going to do a minus b first. Okay, so that would be x minus 3y times a squared. That would be x squared, plus ab, so that would be x times 3y, plus b squared, that would be 3y squared, and then close off your final parenthesis there. All right, now we just need to clean this up a little bit and we'll be done. So this is x minus 3y, and then we'll have x squared. I would probably write this as 3xy, and then 3 squared is 9, so that'd be plus 9y. And there we have it for the sum of, for that example where we have the difference of cubes. Okay, let's look at another one here. Number 8. This one we will have to factor out our monomial first. Again, that means that we're looking for the greatest common factor in each term. So I look at 4 and 23, and I notice that I can take a 3 out of each one of those. And x to the 5th, x squared, I can take an x squared out of both of those. So let's do that. If I take a 3x squared out, I'll be left with 8x cubed plus y cubed. And so if you see 2 things cubed, you might think, okay, this seems really close to a sum or difference of cubes. And it is, it's just not written in like the proper format. So let's do that so that the problem is easier. What number cubed is 8? That would be 2. So I'm going to take 2x cubed plus y cubed. All right, so my a is going to be 2x and my b will be y, following this formula over here, the sum of cubes formula. Okay, so this will leave me with 3x squared. A plus b, that will be 2x plus y. A squared minus ab, so a squared would be 2x squared minus ab, so that would be minus 2xy. Plus y cubed, so plus y, which was, or no, that's it, that's just it, y squared, excuse me, I said cubed, y squared. All right, and then we just clean this up and then we're done. So 3x squared, 2x plus y, nothing changes there. Then we have 4x squared, when we multiply that out, or squared I guess, minus 2xy plus y squared. And then we're done, okay? So that's the factored form of that expression. All right, so we're at 11 minutes. I think we have enough time to go ahead and knock out the last examples here, which is solving. Sometimes you will be asked to solve problems using the method of factoring, and it relies on what is called the zero factor property. So ignore this for a second. The zero factor property says this: if you can factor your polynomial into something like this, just as an example, like, you know, x minus 4, x plus 2, and x, I don't know, minus 12. Okay, it's all equal to 0. If you can factor the polynomial like that, and I say, well, what are the solutions? In other words, what values can you plug into the left-hand side to make it 0? You would say, well, you could plug in 4, because 4 minus 4 is 0. You could plug in negative 2. You could plug in 12. Those would be your solutions to the equation. So if I gave you the expanded form of this and said factor it to solve, you would break it into these 3 parts and then identify 4, negative 2, and 12 as your solutions. Let's try doing that. If I asked you to solve the following here, you would have to think, all right, well, if you're trying to do it by factoring, what factoring rule could I use? Well, it can't be sum or difference of cubes. That's out, right? The only method that we've learned about here is that would fit in this format where I've got 3 terms and one of them is to the 4th power, would be that quadratic form from the previous page that we talked about. So let's try writing this in quadratic form first. And so I'm going to write that as x squared squared minus 4x squared to the 1 power minus 32 equals 0. So then I'm looking for numbers that multiply to give me 32 and combine to give me 4. That will be 4 and 8. Fit the bill there. So I'll have this. I'll have x squared minus 8 times x squared plus 4. And you can see if you FOIL this back out, you would get back to the original here. All right, so now I just want to know, when is x squared minus 8 equal to 0? Well, you can't, 8 is not a perfect square, so we can't use difference of squares, but we can just solve the equation. X squared minus 8 equals 0. So what I'll do is I'll add 8 to the other side. I get this, x squared equals 8. And then I'm going to take the square root. I need to do plus or minus the square root, so I get x equals plus or minus the square root of 8. So there's 2 solutions there. X squared plus 4. We're going to find out really quick here that that does not have any real solution. So if I subtract 4 and subtract 4, I get x squared equals negative 4, square root, square root. You can't take the square root of a negative in the real numbers. We're only looking for real solutions right now in this section, so this one will not produce any real solutions, okay? So that's how you'd solve by factoring. Factor it all up, and then set each piece equal to 0. I'm going to save 10. I don't think we're going to do 10 just because we're running short on time here. Nothing new here. You'd factor out the monomial, and then you'd factor a difference of cubes, and then you ultimately, if you want to try this one, you ultimately get down to x equals 0 and x equals 2. So you might give that a try and see if you can get down to 0 and 2. Last thing I want to talk about is I did put all of the rules that we'd be using here, generally just this concept box on your notes. So greatest common factor example, difference of squares, how that's formatted, sum of cubes, difference of cubes, perfect square trinomials, which those we didn't talk about, but those are review from chapter 3. And then this one, general trinomials, We didn't talk about that one, but oh yes, we did. That was most of chapter 3. That one there. And then this one, factoring by grouping, this one does show up sometimes. So basically the idea is you've got 4 terms, and you factor something out of the first 2, and you factor something out of the second 2. So you get like x out of the first 2, y out of the second 2, and then you factor the a plus b out of both. So if you divide out a plus b from both of these, you get a plus b times x plus y. This one doesn't show up very often, so I'm not making a big deal about it in the notes here. But that one is there as well, because it does very rarely show up. So that is it for section 6. If you have any questions on this video, of course, let me know. Let me know what part of the video you had questions on. And then, obviously, when you're working on your assignment, let me know if you've got questions as well.